So in this video, I will show you how to make a linear regression model in Google Colab. But before we begin, what exactly is linear regression? Well, in layman's terms, linear regression is simply predicting the value of an output using corresponding input values. And so a very good example of that is this image right here, where for example, we could be using x values to predict the corresponding y value. So now for our model, we will be using this CSV file, which is basically just a bunch of data about school students. Here there are many columns on different aspects of the students, and as you can see there are a lot of columns, so we won't going to choose all of them, but we will be using only few columns. First one, we will use this study time, which is the number of hours that the student has studied. Then we also use failures, which is they had failed any exams. So we will also use absences, and then most importantly we will use the grade G1, G2 and the G3, and these columns are just the grades that the students received in each semester. So using this CSV file and these particular columns, that we will be going to create a linear regression model in Google Colab. Now before we begin, it is very important that you all should import the student mat CSV into the Google Colab environment using this button. So without that you are going to get an error. So I will use this in this link. So you can download it directly as a zip file, but from that zip file you only need that student mat CSV. So for this linear regression model, we will first import the necessary libraries, then we use the data to make it usable in our form, then we will actually make the linear regression model, and lastly we can make the model. So for this project we are going to need a few libraries. First we will import pandas as pd, then we import numpy as np, then import sklearn as sk, then from sklearn import the model underscore selection, then from sklearn dot linear model, then import linear regression. As we are going to do this algorithm, we import the linear regression. So we imported all the necessary libraries we needed for our project now. So now we are now good with all the data. Actually this data is equal to pd, so it read the CSV file. So student hyphen mat dot CSV, so that CSV represents that comma separated values. So this so we will separate this by semicolon, and so here we are basically just reading the data set that we have over here and storing it in data. Now our predict variable will be grade G3. Now what this means is, so we are going to use limited columns. So we are going to use 5 of those columns because G3, the sixth column, is what we are exactly going to be predicting using those 5 columns, 5 other columns. So our predict variable for this project is going to be G3, and we can say x is equal to np dot array of data do dropping, then predict 1. So this is our x variable, similar to this x in this image over here. So here our y variable, so we can do np dot array predict variable. So if we run this, it's given as an error. So all of this should be in brackets. So okay, so there we go, and so that's all we need to do with the data right now. So now let's actually move on to our linear regression model. First what we have to do is we have to split this data into train data to train our model, and then test data to test our models, if our model is actually working. So we will do that xt test y x underscore test y underscore train y underscore test, that is equal to sklearn. So do model selection, so do train test underscore split, and then next, which is our x variable up. So here y, and we can say test size, that is equal to 0.1. So all this will do, it will create 4 variables. 2 of them are to test the data, and 2 of them are to train the data. So now we can do linear is equal to sklearn dot linear underscore model dot linear regression. So within bracket we should write is going to be our actual regression model that we are going to use for this project. Now all we do is we do linear dot fit to fit the model onto x underscore train comma y underscore train. So what this is doing is it is practically just training our linear model, which is this one. So you can then do predictions, that is equal to linear do predict, and this will be x underscore test. So this is a variable for actual predictions. So let's run. So this I found what the problem was, and we actually forgot to include a very important line in this data section. So we forgot to include this line. So which is the data that is equal to G1, G2, G3, the study time, failures and absences. So what this is, we are actually defining that we are going to be using these 6 columns when creating our linear regression model. So if we run this, then it should work now. So if you run this model, it works, right? So our model is created. Now all that we have to do is go test our model to see how well it runs. And so now for this I am going to make a loop. I will say for in range. So length prediction, len prediction. So then I will say I have to print within bracket predictions, open the square bracket I comma x underscore test of I comma y underscore test of I. So I run it. So here we can see that our model has just, that we have printed a big block of text, right? So let's actually understand what this means. So the predictions, the first thing, that is printing the value that our model has predicted this array over here. So this symbolizes the other input values that we gave in. So for example, this 10 could be G1, this other 10 could be G2. So this 2, it wouldn't be G3 because that's we are predicting it be the study time, right? And so on. This last value was the actual value for these input variables, right? So for this first example, our model predicted 10.02 and the actual value was 10. So here we predicted 0.07, the actual value was 0 here. For example, we predicted 15.3 and the actual value was 15. So you can see that our model is not 100% accuracy, but is very close to that of actual value what that is supposed to be. So in this video we can make that linear regression model using the student dataset model functions relatively well.